Hey everybody. So I'm going to do a math lesson today, and my hope is to do a few of these while we're off, just so that we can kind of keep our skills sharp as far as fractions go. That's one of those skills that if you stop learning about it for 3 weeks or 4 weeks, then coming back to it can be pretty difficult. So what I'm going to do today is just a review lesson of what we've been learning so far. So my suggestion to you is that while I'm doing this on my board, that you're following along either on a scrap piece of paper or whiteboarded marker if you have it. And then at the end, I will share pictures of a couple optional assignments that you can do. I know people don't have access to printers right now, which is totally understandable because neither do I. So basically it's just handwritten, and you can do it on a separate sheet of paper and send it to me, or they can just do it on a whiteboard as practice. It's just good to keep your skills sharp. So without further ado, I'm going to get started. What we've been learning so far is fractions with equal denominators or bottom numbers, as well as adding and subtracting those fractions, and adding and subtracting mixed numbers, as well as improper fractions, and then changing back and forth between those two. So I'm going to get started on showing you a review of what we've been doing so far. Okay, so the first thing that I want to go over, again, just to review, I apologize, this is not ideal materials, but we're working with what we have. So the first example I want to show you is just finding fractions that we can add together to make wholes. So we know that one whole is always equal to a fraction that has the same number on top and bottom. So what I want to do is break the whole fraction into two separate fractions. So let's say I have 1/4. I want to know what fraction can I add to 1/4 in order to get me 4/4. So I have to say to myself, okay, I know this bottom number is going to stay the same because the bottom number represents the total number of pieces in a whole. So I don't need to worry about doing any other math with my bottom number. I know that's going to be 4. I look at my whole number here and I see that there's a 4 on top, and one of my parts is 1 out of 4. So I have to do a little side math. The total, 4, minus what we already have, which is 1. This answer will give me my numerator here. So we have 4 and we take away 1, we're left with 3. That means that 1/4 plus 3/4 is equal to 4/4. I'll do another example right below it. I'll keep this one so you can see it as I'm doing the next one. Again, I encourage you to follow along with me. If not on a whiteboard and marker, then with scrap paper, just so you can get that practice, because this is one of those things where the more you do it, the easier it becomes. So we're going to do the same process again, this time with 7/7. Again, 7/7 is equal to 1 whole because that is all of the parts. We're going to put this equal to 2/7 plus some fraction. Again, my first step can be filling in this bottom number. I see that my denominator is 7 for both fractions, so that's not going to change. I look here and my whole is 7, and so far I've got 2 out of the 7, so I'm going to subtract those 2, and I have 7 and I take away 2, and that equals 5. So 2/7 plus 5/7 is equal to 7/7, or 1 whole. Leave that up for just a second for you to see. All right, now we're going to move on to a very similar skill, writing each fraction as a sum of two different fractions, but this time the fraction is not always going to be equal to 1 whole. For example, I'm going to start with 5/6. So I have 5/6, and I want to know what fraction plus what fraction is equal to 5/6. So I have to take the top number and break it into two different parts. Same as what we did last time, this bottom number is my total number of pieces. So that's not going to change. That's going to stay 6. We don't add it to anything. We don't subtract it to anything. It's just that whole. So now I have some number of sixths plus some number of sixths equaling 5/6. I have to say to myself, what number plus what number is equal to 5? A really easy approach to this would be to put 1/6 as one of our fractions and then saying to ourselves 5, take away 1, leaves us with 4. So I can say that 1/6 plus 4/6 equals 5/6. This is a skill that your students are going to need to show on the unit test for fractions, is breaking a fraction into 2 smaller fractions. So just like I did with 1 and 4, I'm going to pick another number that's smaller than 5 and put it as one of my numerators. Last time I did 1, so this time I'll do 2. So then I would say to myself 5 minus 2, and the leftover would be my second numerator. So 5 minus 2 equals 3. 2/6 plus 3/6 is equal to 5/6. I'll do another one similar to that one. This one we'll do 8/10. This numerator is an even number, which tells me that I can have the same fraction plus the same fraction equaling 8/10. Meaning, I'm going to figure out what number can I add to itself to get 8. So for that skill, I would have to know how to take 8 and split it in half. So I could draw dots, and I could circle half the dots. Half of the dots would be 4. So 4/10 plus another 4/10 is equal to 8/10. Just like I did with the last one, I can switch it out for different numbers. That would be the even amount, but I can also take, let's say I could pull a 2 out of this, because I know that 2 is less than 8. So I would just take the remainder as my second numerator. 8 minus 2 leaves me with 6, so 2/10 plus 6/10 is also equal to 8/10. Alrighty, the next example I'm going to show is an improper fraction, and I'm going to do the same process. I'm just going to take that improper fraction and show 2 smaller fractions that equal it. An improper fraction means a fraction that has a larger number on top than on bottom. So I'm going to take 12/8, and I want to figure out what fraction plus what fraction can equal 12/8. So same thing, my 8's stay the same. And what I'm going to do is take a number away from 12 that's smaller than 12. Let's do 5. So I'm going to take 12 minus 5. I start with 12 and I count down. When I count down 5 times, I get to 7. So my top number for the first one can be this 5 that I pulled out. And my top number for the second fraction can be what's left over. Notice that when I'm doing this process, there's more than one correct answer. That's the point. The goal is to be able to show at least 2 different ways that each fraction can be split into 2 smaller fractions. So for that reason, I'll show you one more. If you remember up at the top with that first example I showed you, I just pulled out a 1 at first. That's a really easy way to find 2 fractions. So if I take 12 and I just subtract 1, 2 minus 1 is 1. 1 minus nothing is still 1. So I would have 1 for my first numerator, and then the leftover, which in this case would be 11, for my second numerator. So that's just splitting a fraction into 2 smaller fractions. The next skill I'm going to show you is a little bit trickier. We're going to take those improper fractions that we talked about, and we're going to change them into mixed numbers, and then we're going to take those mixed numbers and change them back into improper fractions. So the first one I'll show you is 11 over 8. I'm going to take 11 over 8 and change it into a mixed number, meaning I'm going to have the whole number here plus whatever's left out of 8. So this process is something that we've been working on in class. I've been getting kind of mixed signals about whether or not we understand it, so this would be a really good time for you to really tune in and test those skills. So my first step is deciding how many 8s can I pull out of my top number. I'm pulling out 8s because that's my bottom number. And I want to pull it from the top number because that'll be taking out my whole. So if I count by 8s, I know that I can only put 8 into 11 once because 8, 16 is too big. So I can only pull 1 8 out of 11. So for that reason, I'm going to take 11 minus my 1 8. If I start at 11 and I count back 8, I get to 3. So that's going to be what's left over. I only could put that 8 in one time. So my whole number is going to be 1. And then the answer to my subtraction problem is going to become my numerator because that's the leftover. So what this is saying is 11 over 8 is equal to 1 whole and another 3 8s. 11 minus 8 is 3. That is our 1 8 that we put in, so that represents the whole. And the answer to the subtraction problem becomes our numerator. We're going to move on. I'll show you another one. This one's a larger one. This will give us multiple wholes plus an additional fraction. So I have 26 over 7. Same process. The numbers look a little scarier, but if you've got the process down, then it's the same steps and it should be just as easy. So this time I'm going to take 7s and see how many 7s I can put into 26. This is where knowing your multiplication facts is really going to come in handy because I could say to myself, how many times can I put 7 into 26? Or I could say to myself, 7 times what number gets me as close to 26 as possible without going over. I know that when I take 7 times 2, I only get to 14. So I'm going to try another one because it's pretty safe to say that I can fit in at least one more 7. So I'm going to take this 2 and I'm going to change it to a 3. 7 times 3, I could count by 7s 3 times, or I could count by 3s 7 times. So that would either be 7, 14, 21, or 3, 6, 9, 12, 15, 18, 21. Either way, our answer is 21. I'm going to try 4 because it seems like there's a possibility that we could fit one more in. Let's see. If you're somebody that knows your facts, you'll already know. So when I counted by 3s last time, I got to 21. So this time I'll count by 4s 7 times, and we'll see where this gets us. Let's see if Miss Bryant can remember how to count by 4s. A little rusty here. All right, so we're going to do it 7 times. So I'm going to tap my finger down 7 different times as I count. 4, 8, 12, 16, 20, 24, 28. So the answer to this is 28, and what I needed was a number that is as close to possible as 26 without going over. So for that reason, I can only fit 7 into 26 3 times. So that number is going to become my whole because I can fit 3 of those 7s. When I fit 3 of those 7s, the number I get is 21. So we're going to take our original numerator, 26, and we're going to subtract the 21 from it. 26 minus 21, I'm going to do my 1s column first. 6 minus 1 is 5, and 2 minus 2 is nothing. So this answer to my subtraction problem is going to become my numerator for my mixed number. I have 5 pieces left out of 7 after I convert all my wholes. So 26 sevenths is equal to 3 5 sevenths. That's probably the most complicated skill we've done so far in fractions. So if you're thinking to yourself, wow, I'm confused right now, I'm sure you're not alone. That's why we're doing this. I'm going to do another one. I'll leave this up for another few seconds just so you can soak that in if you need to. All right, I'm going to move on to another one. This time, I'm going to take a mixed number that's already formulated for us, and we're going to go backwards, and we're going to change it back into an improper fraction. So we're using the same type of skills. You'll just notice that it's going to be completely reversed. So I'm going to take 3 2/5. I know that this is a good to go mixed number because I have a whole, and then I have a top number that is smaller than my bottom number, or a numerator that's smaller than my denominator. So I'm going to take this 3 2/5 and I'm going to change it into an improper fraction, meaning my top number is going to be much bigger than my bottom number. Now, something we can already fill in is that bottom number. What we're doing here, the bottom number is always going to stay the same. It will throughout this entire lesson. So don't worry about doing anything with that bottom number. It's always going to stay the same within this lesson. So, what this 3 is representing is how many 5/5 there are in this number. So that means there is 5/5 plus 5/5 plus 5/5 in this number, plus the 2/5 that are left over. So a really easy way to solve this is I could take and I could just group these two. So I could do 5/5 plus 5/5 and then 5/5 plus 2/5. 5 plus 5 equals 10. And again, bottom number stays the same. 5 plus 2 equals 7. And that bottom number still stays the same. Then I take what I have grouped and I add those two. 10 plus 7, that's a really nice number to add because we can add anything easily to 0. It's just itself. So we have the tens column is 1, and then the 0 plus 7 makes our ones column 7. And that trusty bottom number stays the same. So 3 2/5 is equal to 17/5. Another way to look at it would be 5/5 times the 3 times that we could put it in. Take that answer, because all we're doing is multiplying the top number and keeping the bottom number the same. So I could take 5 times 3, that equals 15. I could count by 3s or 5s. 5, 10, 15, or 3, 6, 9, 12, 15. So I could take that 15 over 5. I'm going to rewrite it down here so I have a little more room, plus the 2/5 that are left over. 15 plus 2 equals 17. Number that I get is still 17 over 5. Going from a mixed number to an improper fraction, I would say has just a little more written work involved. But as you notice, it's the same kind of concept, figuring out how many times it goes into a certain number. This time we're just doing the reverse. I'm going to go ahead and do one more example. And then I think we'll call it quits for the day. I planned on doing a little bit more, but it's a lot to soak in. So I think we'll split it into 2 sessions, and this will be our last kind of example for the day. So I'm going to take another mixed number, 2 3/10. And I'm going to use the same process to turn that into an improper fraction. So I already know bottom number stays the same. So what this is saying is there's 2 10/10 plus another 3/10. So I take those 2 10/10. those together. 10 plus 10 equals 20 over 10. And then I still have to add in this leftover 3 out of 10. Again, 20 is another really nice number to add with because that ones column is a 0, so adding things to it is super easy. We know that 0 plus 3 gives us 3, and then the tens column stays the same, 2. So we have 20 tenths plus 3 tenths equals 23 tenths. So 2 and 3 tenths is equal to 23 tenths. All right, that's all for today. Like I said, I'll post a little example sheet as a photo on Class Dojo so that you can have a little practice if you'd like it. Please make sure you're keeping up with these skills so that you don't forget them. When we come back, we'll be continuing on with fractions, so make sure you're ready to go. All right, we'll see you soon.